Hello my dear friends and welcome back to the DSA class. I hope day by day your logic is building up and I'm sure your dream of getting placed in a beautiful product based company is just a couple of programs away. Anyways, today I have a very exciting program lined up for you. Just have a look what the program is. I hope you read the program. Maybe it made sense to you, maybe it did not make sense to you. Let me explain the expectation of the program. From the user, you are going to take a value n, right? Now, whatever value you take, it's factorial you have to find. For example, 5 factorial. Now, you don't have to tell them what is the value of 5 factorial. No, that is not the thing. Calculate what is 5 factorial. You know if I calculate 5 factorial, it's 1 into 2 into 3 into 4 into 5, and if I multiply everything together, I get 120. Now, you must say, in the factorial of 5, at the end, how many zeros are there? How many zeros at the end is also called as trailing zeros. I hope you're able to understand. How many trailing zeros are there? Just 1, and that 1 should be your output. Another example, 8 factorial. All of you know how to calculate 8 factorial. This is the multiplied result. Tell me how many trailing zeros are there. Now don't foolishly tell me that there are 2 zeros. No, my dear friend. Trailing zero is only 1 because there is only 1 zero at the end. This is not a 0 at the end. So there is only 1 trailing zero. Any confusion till here? One more example, 10 factorial. All of you know how to calculate 10 factorial and this is the multiplied result. How many trailing zeros are there? 2 trailing zeros. Any confusion? Now, how are we going to write a program which is going to calculate this for us? Now, there are 2 approaches. One is go through the hard approach. First calculate the factorial, then take the final product. After that, start counting how many zeros are there. But that too, not all the zeros, only trailing zeros. I think if you just start creating the logic in your mind, you might understand that it is quite complex. And you are a human being. You can skip steps and calculate. Computer doesn't have intuition like us. It works one step after the other, after the other, after the other, which means in terms of processing power, in terms of effective utilization of CPU, whatever logic you come up now will not be efficient. But the beauty of mathematics is there are really efficient ways to calculate such things. Let me show you a trick. Look at this, my dear friend. Forget about 120. Look at this factorial. Can you tell me how many 5s are there in the factorial? As you can see, there is 1 5. How many trailing zeros? 1 trailing zeros. Do you see a direct correlation between the number of 5s and the number of trailing zeros? Similarly, look at 8 factorial. How many trailing zeros? 1. How many 5s? Just 1. 1, 1. Let us take 10 factorial. How many trailing zeros? 2. How many 5s? Now you might say only 1 5, Rohit. Correct. Then the logic failed. That's where you are wrong. There is another number here which can be expressed as a factor of 5, which is a multiple of 5. Which is that, can you tell me? Yes, you are right. That is nothing but 10. And 10, you know, can be split and written in a certain way, which is nothing but 5 into 2. So if 10 is expressed as 5 into 2, now count how many 5s are there? 2 5s. How many trailing zeros? 2 trailing zeros. Which means without having to calculate the factorial itself, you are able to calculate how many trailing zeros would be there at the end of that number. Any confusion till there? Now, how can we write this as programming logic? That is the question. Let me show you. Before that, let's take another example, right? For example, if in case I were to take 25 factorial, right? Now, you know 25 factorial is a huge number. If in case I express this 25 factorial, then it is 1 into 2 into 2, that till 25. If I multiply all of it, it's such a big number that you would be getting. Now, please look at this and tell me how many trailing zeros are there. As you can see in the end, there are a total of 6 trailing zeros. It would have been a nightmare to use a traditional programming approach to solve this. But let me show you an even better and smarter approach. Watch it. If in case we start counting 5s, this is the first 5. Yes, first 5 you have counted. Which means if you count only the 5s, there is only 1 5, but there are 6 trailing zeros. So that is a mistake. You should count all possible 5s. And how will you find all possible 5s? Simple. Look for all the multiples of 5. Can you tell me which are the multiples of 5? Obviously, these are the multiples of 5. 10 is a multiple of 5. Similarly, 15 is a multiple of 5. Similarly, 20 is a multiple of 5. 25 is a multiple of 5. All these are nothing but what? Multiples of 5. Any confusion till this point of time? If they are multiples of 5, they can be factored and expressed in terms of 5. How, you ask me? You already know it. 10, how will you represent it? 5 into 2. 15 is 5 into 3. 20 is 5 into 4. 25 is 5 into 5. As simple as that. Now if you count the number of 5s, 1, this is the second 5, this is the third 5, this is the fourth 5, this is the fifth 5. Sixth 5, I'm sorry. So 1, 2, 3, 4, 5. Any confusion till this point of time? And there is obviously one more, which is the sixth 5. So see, 6 5s, 6 trailing zeros. Direct correlation. Beautiful, isn't it? But again the question is, how will I write this as a logic, sir? Wonderful. Yes, we understood that there is a correlation. But how will I write it as a program? Don't worry about it, I will show you. But to better understand the logic that you have to write, let me first represent it in the form of a table for you so that you better understand what I'm saying. My table has 3 columns. Factorial, something called as operation, and something called as number of zeros. And when I say zeros, it is not total zeros, it is trailing zeros. Any confusion till here? And that is why here I am just showing you trailing zeros. Any confusion till this point of time? Now please understand. Let us start. I'll start with 5 factorial. Now I'm going to do one operation. What is the operation is? I'm going to take 5, which is nothing but n value which I will take from the user, and I'm going to divide it by 5. See, I'm just going to divide it by 5. 5 divided by 5 I'm going to do. And that is what I'm also just showing you here in the operation. As you can see, I'm doing 5 divided by 5. Tell me, if you divide 5 by 5, what is the output? 1. The result is 1, and that is nothing but the number of trailing zeros which you can see here. This is only 5 factorial. Similarly, let us take the next example, 10 factorial. This is the number 10 factorial. Take 10 divided by 5. If I divide it by 5, what is the output? 2. How many trailing zeros? 2. Matching. Beautiful. Next one, I will take 15 factorial. That is 15 factorial. If I take 15 divided by 5, what is the result? 3. How many trailing zeros? 3. That is matching. Similarly, if I take 20 factorial, you know this is only 20 factorial. How many trailing zeros are there? 4 trailing zeros. See what I will do? Take 20 divided by 5. 20 divided by 5 is nothing but 4. Matches. But if I continue this forward, will it work for all the factorials? Let us see. I will take 25 factorial, let us assume. You know this is only 25 factorial. How many trailing zeros? 6 trailing zeros. If I take 25 divided by 5, my friend, how much did you get? Did you get 6? No, what you got is 5. That is what you got, which is what I am also just showing there. 5 is what you have got. So clearly, at one point, this fails. At one point, this fails. But if this had to work, instead of 5, I should have got 5 and you should have got a +1. Now, is there a way to write code in a generic way such that I will get this 1? Very simple. So far, whatever we have written, let us generalize it. This 5, 10, 15, 20, 25 is nothing but the n value that you will be taking from the user, right? That is what I am also just showing like this. It is nothing but n factorial. What is this operation you are doing? This 5, 10, 15, 20, 25 is nothing but n value. 5 is anyways fixed, which means in general if I have to write, how can I write it? N divided by 5. Would you agree with me? Now this n divided by 5 works for everything up until 25. After 25 and after that it will not work. So then what to do? What to do is, I need this 1, isn't it? To get this 1, I am going to do a simple operation. What is that operation? See, I am going to add to this, plus I want, isn't it? So I am going to add to this n divided by 25. Now you might ask, how did I arrive at this n divided by 25? I will tell you that. But for the timing, let us assume n divided by 25. If I apply this, will it work? Let's see. 5 by 5 plus 5 divided by 25, n by 25. Similarly here 10 by 25, 15 by 25, 20 by 25 and finally it is 25 by 25. If you evaluate it, 5 by 25, when the numerator is less than the denominator and you perform division, what do you get? 0. That is what I am also showing there, plus 0. Numerator is lesser than the denominator, what will you get? 0. Numerator is lesser than denominator, what will you get? 0. Numerator is lesser than denominator, what will you get? 0. Numerator and denominator are equal in value, what will you get? 1. And hence, all this evaluates as to the same 1, 2, 3, 4, but this now becomes 6. Any confusion till here? Wonderful. Now the question will be, sir, how did you arrive at this n by 25? It's very simple. I arrived at it because there is a series like this. What is that series? Would you like to know? Let me show you, my dear friend. This is how the series look like. I am just taking this and I am just keeping it there. And I am just showing you that the series extends. It doesn't stop here. N by 5, n by 25. Can you guess the next term in the series? N by 125. Can you guess the next term in the series? N by 625. Can you guess the next term? N by 3125. Like that it will ultimately go till infinity. Yes, this is a series. It will go till infinity. Would you agree with me? Now, the same thing, if you look at it, and if I have to generalize it, I am just duplicating it like this for you. This 5, 25, 125, 625, 3125, do you notice it is nothing but the powers of 5? 5 to the power 1, 5 to the power 2, 5 to the power 3, 5 to the power 4, 5 to the power 5, so on and so forth. Would you agree with me? Now, will this series help you calculate the trailing zeros in a factorial is the question. 100% it will. How? Let us take a sample input and check, shall we? So watch it, my dear friend. What I am going to do now is, like this, I am just going to take an n value. Let us assume the n value this time is the simplest n value I can take, which is 5. Let us apply it to this. So watch it. If I apply it to this, first is n divided by 5 to the power 1, which is nothing but 25. Right? So 5 to the power 1 is 5, 5 to the power 25, 125, 625, like that. Till infinity it goes. But if I mathematically reduce it, 5 divided by 5 is 1. Rest everything is going to be zeros because the numerator has become lesser than the denominator, and that is the key point which should get drilled into your minds. Yeah. Now, add up all of this. Yes, 0 till infinity it will go. Add up all of this. What is the result you will get? 1, which is nothing but the result of your program, which is what I will also just be storing it in a variable called as result. And there the value is going to be 1. Any confusion till here? Let us take another input, shall we? For example, let us take another n value. This time the n value which I am going to be using is probably a larger n value, and this time 200 I am using. Will it work? 100% it will work on this series. Let's apply it. If I apply it, 200 plus 5 plus 200 divided by 25 plus 200 divided by 125 plus 200 divided by 625, like that it keeps going on. But if you notice, 200 divided by 5 is nothing but 40 plus 8 plus 1 plus 0. Why did it become 0 here? Because at this term, the numerator became lesser than the denominator. Would you agree with me till this point of time? So what, you might ask? So what if you ask me? This series is there. To generate this series is not a big deal, because all you have to do is, whatever n value is given to you, take that n value, divide it by the first power of 5, which is nothing but 5. 5 to the power 1 is 5. Next time, take the same n value, divide it by the next power of 5. And how will you go from one power of 5 to the next power of 5? Multiply it by 5. 5 into 5 is 25. Next power you want, 25 into 5 is 125. Next power you want, 125 into 5 is 625. So generating the series is not a big deal. But how are you going to write code in such a way that your code foolishly is not going to continuously calculate till infinity? Rather, smartly, it must immediately terminate the moment the first 0 is encountered. And if you notice, here the first 0 is encountered at this term because numerator became less than denominator. Here the first 0 is encountered, and obviously if I add all of this, it is 49, which is nothing but the number of trailing zeros, and that is what I am storing in a variable called as result as well. But the important part here is, when does the first 0 come? When the numerator becomes lesser than the denominator, in other words, this term. So how will you write code such that you will keep calculating till the first 0 is encountered? As simple as that. Well, I think already 99.9% of you can write the logic on your own, but if I have to spell it out explicitly for you, this is how things would look like. This is n. This is my variable result. Initially always, result will not have any value, it is going to be 0. Initially it is always going to be 0. What I am going to do is, I have to calculate the powers of 5. It's very important for me. So I will create a variable which I will call it as power of 5 like this. Tell me, what should be the initial value of power of 5? Should it be 0? Then you are not thinking. If you said 0, you are not thinking, because the initial value of the power of 5 is nothing but the first power of 5, is nothing but 5 to the power of 1. And what is 5 to the power of 1? 5. Any confusion till here? Next, what you might ask? Now comes the core logic. We have to start doing this division. How will you do this division? Very simple. All you have to do is, ultimately in result only you have to store it. So what I will do is, I will tell, hey listen, take n, divide it by whatever is the existing value of the power of 5. That result you take, right? Add it to the existing value of result and update it to result. That is what I will be doing. And if I just apply the logic here, what is the value of result now? 0. What is the value of n? 200. What is the existing value of 5? 200 by 5. So 200 divided by 5 is nothing but 40, 40 plus 0 is nothing but 40, and that becomes my updated value of result, which is what I am showing here. Any confusion till this point of time? Amazing. Now, I want to repeat this operation, because see, you have to again divide n by the next power of 5. But right now, if you repeat the statement, power of 5 will still be 5. But I want the next power. Next power is 25. 5 square of 5 to the power 2 is 25. So how will I update it? How will you go from 5 to 25? Simple. Take the existing power of 5, multiply it by 5. How will you go from 25 to 125? Multiply by 5. Did you get the logic? Which means it's very simple. All you have to do is, in the next step, update the power of 5. How will you update it? Take power of 5, which is your existing value, multiply it by 5. Next power you will get, update that as the value of power of 5. If I apply the logic here, 5 into 5 is 25, and that is what I am going to be updating. Any confusion till this point of time? Beautifully it works. Now, this process has to repeat. Now you have to take the next n value, divide it by the new power of 5, update it as result. But mechanically you should not be looping here, because there is a condition which we arrived at where this process should stop. See here, n divided by power of 5, but I stopped in the next term. Why? Numerator became lesser than the denominator. N divided by power of 5, n divided by the next power of 5, n divided by the next power of 5, but here I stopped because numerator became lesser than the denominator. Which means always before dividing n by the power of 5, taking that value and updating it to my result, I have to first check whether the numerator is actually greater than the denominator. As long as it is greater than the denominator, I can continue. The moment it becomes lesser, I should stop. And hence, here I should apply a condition. What is that condition? You said numerator should be greater than or equal to the denominator. And that is what I am also just writing here, as n should be greater than or equal to the power of 5. Or one more way to read this is, numerator should be greater than or equal to the denominator. In this case, it's nothing but the power of 5. Now, if this condition is satisfied, this should loop, this should repeat. Now, it should keep repeating as long as this condition is satisfied. So, I want as long as effect. How will you get as long as effect in programming? Simple, there is a loop for it, and the name of the loop is only while loop. As long as n is greater than or equal to the power of 5, as long as this is true, keep doing this process. The moment it becomes false, stop and exit. Would you agree with me? So that's what I'm going to do. Let us apply it first time. Now, you did it. See, numerator value is n, 200. Is 200 greater than or equal to 25? Yes. Yes means enter. Apply it. If I apply this logic here, all I have to be doing it is just this. So watch it. I'm just showing you 40 plus 200 divided by 25. So 40 plus 200 divided by 25 is I think 8. So 40 plus 8 I will be getting 48, and that is going to be my new result. This is what I'm showing. I will update that to result. Any confusion till this point of time? Next, update the power of 5. So existing value is 25 multiplied by 5, you are going to get 125. Once you get 125, update that as the new value of power of 5, which is what I am also just showing. 25 into 5 is 125, update. Any confusion? Now again, you are within a loop. Check for the condition. Is n greater than or equal to the power of 5? Yes, it is still greater, which means condition is true. If it is true, enter. Once you enter, just apply the same logic because you are within a loop. And here I will just go and in result I will tell 48 plus 200 divided by 125. 200 divided by 125 you know is nothing but 1, and 48 plus 1 is 49. Update that as the new value of result. Next, update the power of 5. If I update the power of 5, 125 into 5 is nothing but 625. Update that to the power of 5. Now I am within a loop, which means again I will check the condition. What is the condition? Is n greater than or equal to power of 5, which is 625. 200 is not greater than 625. 200 is not equal to 625, which means the condition becomes false. If the condition becomes false, stop your looping, come out of the program, take your result, return it as output, and ultimately the result is going to have the number of trailing zeros in 200 factorial. Beautiful logic. Very crisp logic, and this is the kind of logic which will impress an HR in the interview round, because it is not about getting the desired result, it is about how you got the result. It is about how efficient the code is, how less processing power it took in your CPU, how much less memory it took in your computer. All these factors play a huge role, and that is the duty of this course, to instill that kind of a programmatical thinking in all of your minds. Anyways, now it's time to write code for it. Let's go type some code. Let's write some code in Java, shall we? My dear friend, I have my class called as alpha and I have my main method ready. Now, first thing is I would like to create a method called as trailing zeros, which is where I'm going to write this logic. So I'll go on top of the main method, and as usual, there is no need for object creation. I want this to be a utility method. A utility method is such a method which does not require object creation for it to be called, and such a method is nothing but a static method. So I'll tell static, and because I will be returning this result, which is an integer, I will tell this is a method which will return an integer, and the name of the method is trailing zeros. So I will use the conventions and write it trailing zeros. Wonderful. And it is going to accept this n, which is an integer. So I will tell int n like this. Next, inside that, you know you require two variables. One is result, another is power of. Result initially is 0, power of initially is 5. So int result equal to 0, and maybe you can make it as res itself. Yeah. And I will tell int power of equal to 5. That's what I'm going to do. Int power of 5. Power of 5 equal to 5. Wonderful. Next comes our while loop. So I will tell while, and inside that is your simple condition, which is n should be greater than or equal to the power of 5. If that is so, I will come inside and I am going to just do this logic. So I will tell result is equal to the old value of result plus n divided by the power of 5. Yeah, maybe I'll put that within brackets for better readability. Superb. Next time you want the power of 5 to be updated, and that's what I'm going to do. Power of 5 is equal to old power of 5 into 5. Awesome. At the end of the loop, result will have the number of trailing zeros. I'll come out of that, return it. So I'll just tell return result. Amazing. Now I'm going to come inside the main function, and all that is left is, first of all, you should be able to take input from the user, and you know for that scanner class is there. I'll create an object of the scanner class. So scanner type SC, is equal to new scanner of system.in. Beautiful. And obviously, you know, you will have to import this as well, and that is what I'm just going to do there. I'll go to the top of my program and I will just import that scanner class from the java.util package. Next, I'm going to come down and anyways, what I'm expecting is an integer value. So I will tell sc.nextInt. And that I am just going to store it within a variable called as n. Naturally, n has to be of type integer. Next, I will be coming down and what we will have to do is just call this trailing zeros function. So I'm going to do that. I'll call trailing zeros and I will pass n. Now it will return me the result which I want to print. So I'll just cut this and I will tell system.out.println. I will just paste it so that it directly gets printed. Now watch it, let's go execute and check whether it really works. If I take you back to the output window and if in case I put in the relevant command to compile it first. So I'll tell javac alpha.java, which is the name of the source file. If I press enter, compilation is perfectly successful. Let's execute it by telling java followed by alpha. If in case I press enter, then it's waiting for input. 5 is my first input, correctly it is telling 1 trailing 0 like this. I will re-execute it. 25 is my second input, correctly it is telling 6 trailing zeros. I will re-execute it. 200 is my next input, it is correctly telling 49 trailing zeros. It works. It works and it works perfectly, my dear friend. So what I want you to understand is that complex problems oftentimes have simple solutions. And it is our duty to instill that thinking in you such that you are not just writing code, but you are writing elegant, efficient, beautiful code, and in the process fall in love with coding. I hope as days pass you're getting more and more excited to master data structures and algorithms, and definitely this will result in you getting placed in your dream product based company. This is all from my side in this video. See you in the next class.